energy. Okay, now the second way of determining the lattice energy, although not 100%, is using the Born-Haber cycle, which relates the lattice energy of ionic compounds to ionization energies, electron affinities, and other atomic and molecular properties. So in this case, in this example, we will use the lithium fluoride. No? So this is the 3D illustration of a lithium fluoride. So how does it, or how do we start this? Of course, we start this by simply putting our attention to the Hess law also. Okay? So anong first step nun? Conversion of solid lithium to lithium vapor. And in this case, it requires 155.2 kilojoules per mole. Okay? So we're taking into consideration what's happening and of course, ang yang energy. So that's the first one, the sublimation of the lithium. The second step is the dissociation of the half of the mole of the fluorine gas into separate gaseous F atoms. So in this case, we separate kasi fluorine, dalawa siya, it's diatomic, no? So diatomic siya in this case. So the dissociation of that into a single fluorine atom, it requires 75.3 kilojoules per mole. The next step is the ionization of 1 mole of gaseous lithium. Ayun. And in this case, it will release an electron and that will require 520 kilojoules per mole. The next step is the addition na pod of 1 mole of electron to 1 mole of gaseous fluorine. No? Kay na-add naman nato to siya and then kato from the ionization of the lithium man tong isa ka electron. So in this case, the electron now will be added to the fluorine atom or in the gaseous form. And this requires since it is negative, so it requires the removal of 328 kilojoules per mole na energy. Okay. The next or the last step is the combination of 1 mole of gaseous lithium and 1 mole of F2 to form 1 mole of solid liquid fluorine. So in this case, it started from the dissociation of your lithium and fluorine into gaseous form muna. And then in that case, it will be combined to form a solid form of that compound, which is lithium fluoride. Now, in this case, what is the energy? No? What is the energy required nga gikan sa, 'di ba, nagsugod man taog katong solid lithium, no? Dissociate into or ni sublime into gas. Then fluorine gas dissociate into individual fluorine atom. Then we ionized the lithium to get 1 electron, and then the electron is added to the gaseous fluorine. So in this case, they will now produce a solid lithium fluoride. So in that case, how do we know the energy? So very simple. We simply go back. We add all of them, and then we can create an overall expression based on the Hess law. So we can write that the overall energy is simply equal to the sum of all of their energies. So in this case, we do not have the H5, no? So what are we going to do? Very simple. We simply get this value and we have the overall value. So ato lang siyang i-deduct so that the remaining answer will be the value of your H5. So that is the energy actually in the fifth step. Meaning, that's the energy na where our lithium and our fluorine can combine. Nga naman, if that's the energy required for the lithium and fluorine to combine, that's also the same minimum energy required to separate them. Diba? So again, we have here a result of negative 1017 kilojoules per mole. So this is now the value resulting to that. So again, I will repeat, that is the value here in our fifth step, no? Mo na value nato sa fifth step. Remember, if that is the energy required to combine lithium and fluorine, that's also the minimum energy required to separate them. Now, if we're talking all about energy and then we see a negative sign, automatic, it's the removal of that energy. But remember, or take note of this pala. The lattice energy of lithium fluoride in this case is 1017 kilojoules per mole. It's at a negative 1. Why? Because the separation of ions in a solid into ions in the gas phase is by Coulomb's law an endothermic process. So we can have a positive a positive value of the lattice energy. So that's how we use the Born-Haber process to determine the, although not 100% the exact value, but at least we're trying to determine the lattice energy of some of the ionic compounds. So in this case, we're using lithium fluoride. So again, if it's not enough, or if this information is not enough for you, you may also check other sources, and you may also check the chemistry book by Raymond Chung, 10th edition and higher. Okay? So, knowing all of those, we started our discussion with how are the ions, or how ions are formed, what's happening in the process. Then we also discussed the Lewis dot structure, naming, 'di ba? And then our last discussion focuses on the lattice energy. So using all of those information, we can now have the characteristics or properties of ionic compounds. So, let's start muna with physical properties. Ionic compounds are solids, 'di ba? Just like this is related to the lattice energy. Ionic compounds are solids and are hard to break due to the strong force of attraction between the positive and negative ions. The best example nito is the sodium chloride, no? The table salt. Yeah. This is the best example of this one. Imo lang ng anaon, although mahilis siya, no? Pero it's really difficult for you to break compared to other compounds. However, they break into pieces when pressure is applied. So they are considered brittle, no? Considered brittle gyapon dahil sila. Even though there is a strong connection between their ions, they are still brittle, no? So dili siya guarantee. Di in the world, dili guarantee nga kung strong ang inyong connection, unbreakable na mo. 'Di ba? So dili gid siya guarantee, guys. Okay? So the next one here is melting point and boiling points of ionic compounds. A large amount of energy is required to break the ionic bonds between the atoms. So, sa effect? Effect, ana, they also have high melting and boiling points. No? Kay kuan man, taas man kaayo ang energy nga i-require para ma-break ang ilahang bond together. So, ana siya? Dapat, taas pud ang, so, there is a large amount of energy, so ang result, taas ang ilang melting and boiling points. Okay? Next is the solubility of ionic compounds. Ionic compounds are generally soluble in polar solvents, such as water. What do you mean by polar solvents? These are solvents that are polar, meaning they have a positive. The best example actually is water. Na siya positive nga side and negative. Nga naman, since ionic compounds really naagid siya cation and anion. So dito po siya mo interact with the positive side and the negative side of your polar solvents. So mao nang grabe gyud siya ka-soluble. Okay? So in return, since soluble man siya sa polar, dili pud siya soluble sa non-polar solvents, just like petrol, gasoline. So I remember when I was a child, no, we have this lampara ba na we put salt there and then we add a lot of oil para himuon siyang lampara. So the salt will really stay there as salt as is because oil is a non-polar solvent and salt is an ionic compound. 'Di ba? So dili gid siya soluble. Non-soluble. Yes. And the last one is the conduction of electricity. As a result, if you have salt, for example, since this is the best example of ionic compound, if the salt will be dissolved in a polar solvent just like water, there is now the separation of this, the positive and the negative side, or the cation and the anions. They will now become a very good conductors of electricity. Remember, although ionic compounds do not conduct electricity in the solid state because movement of ion is not possible, they are best conductors of electricity when they are in molten state or they are in dissolved state. No? Kanang ingana. Nga naman, because electrostatic forces of attraction between the ions are overcome by the heat released. So ingana siya, although if you simply put the kanang na tester, tapos kung musiga ba siya or dili, kung ingana lang nimo siya sa solid nga sodium chloride, wala may tabo. Pero if ma slightly melted na siya or molten or ma ano na siya kanang i-dissolve na nimo sa polar solvent just like water, kuha na kayo siya. Very, kusog na siya mo conduct og electricity. No? So again, these are the common properties of ionic compounds which are really connected to our previous discussions. Okay? So, ano sa to? We started with the three types of kanang or we started with a definition of chemical bonding, then the three types of chemical bonding, then I discussed to you how these cations and anions are formed, then we discussed also the Lewis dot structure, naming the transfer and the receiving and transferring and receiving of electrons, and of course the lattice energies and the properties of this ionic compound. So I hope you really learned something in our session today, although it's very ano lang no, limited. So you may also open or check other sources. I'm using the kuan college I sorry I'm using chemistry by Raymond Chang, and also conceptual physical science by John Paul Hewitt, and others also. You may also open them, no? And also other textbooks. So again, thank you so much for checking this session, no?